In a mind-bending phenomenon, entire galaxies can transform into a swirling vortex of cosmic dust in a matter of millions of years. The transformation, known as a galaxy collision, occurs when two massive galaxies collide at high speeds. The resulting impact sends shockwaves throughout the galaxies, causing stars, gas, and dust to be flung outward. Imagine a cosmic dance of gravity and energy, with galaxies as the lead performers. Galaxy collisions are not rare events, as they occur with a frequency of about 1 every 100 million years. But that's not the strangest part. Some galaxies can even merge into a single, supermassive galaxy. The merger process can take billions of years to complete, with the final product being a giant, spiral-shaped galaxy. To visualize this, imagine a giant whirlpool of stars and gas, with a central black hole at its core. Galaxy collisions are not just a matter of cosmic curiosity. They can also affect the formation of new stars and planets. But wait until you hear what comes next. Some galaxy collisions can even trigger the formation of supermassive black holes. These black holes can grow to be billions of times more massive than our Sun, with the power to warp space and time. One such example is the supermassive black hole at the center of the Milky Way galaxy, and it's the key to understanding how supermassive black holes grow. Sagittarius A** has a mass of approximately 4 million times that of our Sun, and is surrounded by a disk of hot, swirling gas. This disk of gas is known as an accretion disk, and it's the key to understanding how supermassive black holes grow. The accretion disk is fed by the collision of stars and gas within the galaxy, which are pulled towards the black hole by gravity. As the gas falls towards the black hole, it becomes hotter and more energetic, releasing X-rays and other forms of radiation. But that's not the end of the story. The radiation from the accretion disk can also affect the formation of stars and planets. This is because the radiation can ionize the gas, making it difficult for new stars to form. However, some galaxies have managed to avoid this problem by having a large reservoir of cold gas, which can cool and condense to form new stars. One such galaxy is the Andromeda galaxy, which is approaching the Milky Way at a speed of about 250,000 miles per hour. The Andromeda galaxy is thought to have a large reservoir of cold gas, which will allow it to continue forming new stars even after the collision. This collision will be a spectacular event, with the two galaxies merging to form a new, giant galaxy. The final product will be a galaxy with a supermassive black hole at its center, surrounded by a disk of hot, swirling gas. This galaxy will be a new home for many stars, planets, and other celestial objects, and will be an exciting place to explore. But that's not all. The collision will also trigger the formation of new stars and planets, which will be shaped by the strong gravitational forces. This process will be repeated many times over the next billion years, as the new galaxy continues to evolve and change. As we look out into the universe, we see many galaxies undergoing similar transformations, each with its own unique characteristics and features. From the majestic spiral arms of the Milky Way to the chaotic collision of galaxy clusters, the universe is full of fascinating phenomena. The study of galaxy collisions is an active area of research, with scientists using observations and simulations to understand the processes involved. One of the key challenges is to understand how the collision affects the formation of new stars and planets, and how this affects the overall structure of the galaxy. To tackle this problem, scientists are using advanced computer simulations to model the collision process and predict its outcomes. These simulations are based on complex algorithms that take into account the properties of the galaxies, such as their mass, size, and composition, which has created a detailed model of the collision between the Milky Way and the Andromeda galaxy. Scientists can create a detailed picture of the collision process and its effects on the galaxy. One such simulation is the Illustris TNG project, which has created a detailed model of the collision between the Milky Way and the Andromeda galaxy. The simulation shows how the collision will trigger the formation of new stars and planets, and how this will shape the overall structure of the galaxy. The results of the simulation are a testament to the power of computer modeling in understanding complex astrophysical phenomena. By using simulations to study galaxy collisions, scientists can gain a deeper understanding of the processes involved and make more accurate predictions. This knowledge can then be used to better understand the evolution of galaxies over cosmic time and to predict the formation of new stars and planets. In conclusion, Galaxy collisions are a fascinating phenomenon that can have far-reaching effects on the structure and evolution of galaxies. The study of galaxy collisions is an active area of research, with scientists using observations, simulations, and modeling to understand the processes involved. As we continue to explore the universe, we will undoubtedly discover more galaxies undergoing similar transformations. But for now, let's take a closer look at the Andromeda galaxy and its approaching collision with the Milky Way. Subscribe for more incredible stories like this, and don't forget to like and comment below with your thoughts. If you have any questions or topics you'd like to discuss, please let us know in the comments. We'll be happy to answer your questions and engage in a conversation about the amazing universe we live in. Thanks for watching, and we'll see you in the next video.